Hello and welcome. This is going to be our Unit 1 study guide review video. Hopefully you're watching this to get ready for our test. I'm going to do a selection of problems here. This is a great way to start your studying, or a good thing to come back to if you've already finished the review guide and you just want to see me talk through a couple problems here. All right, starting with problem number 1, we're being asked to solve each equation. What we want to do when we're solving these equations is first simplify by distributing and combining like terms, and then look to isolate our variable on one side of the equal sign. Now there's no one right way to do these problems. Sometimes it's a better idea to distribute, sometimes it's a better idea to divide away a coefficient. First thing I'm going to want to do in this one is combine this -8 with its like term over here by using an inverse operation. I've got -6 times the quantity 5r plus 4 equals -6r plus 48. I think it's going to be a better idea here now to divide by that -6. I see these are both divisible by -6. So I'll save myself a step by just dividing everything by -6 right here, canceling out that -6. Now I get a 5r plus 4, that's what's left on this side, equals, that's a negative divided by a negative for a positive r minus 8. Let's go ahead and now I want to get all my r's together and get all my like terms together. Do that by subtracting an r from both sides. 4r plus 4 equals -8. Subtract 4 from both sides. Now I've got 4r equals -12. Divide by 4, divide by 4. And we want to report our answer as r equals -3. Number 3 and 4 are kind of interesting problems as we go through the process of solving them. In number 3, we're going to distribute that 2. We'll get -4r. And when we combine that with the 5r, we'll have an r on this side, but it'll be an r plus 2 equals r plus 1. The r's cancel out, and we get 2 equals 1. If we reach a contradiction like this, we want to say that this equation has no solution. Now in this one over here, if I distribute that -5, add 25 to both sides, or maybe you could subtract 5a from both sides, you might get an equation like -25 equals -25. If we reach a situation where all of our variables cancel out, but we're left with an identity, a true statement, then we want to write that we have all real numbers as solutions. So all real numbers. There is no number we couldn't plug into this equation and get a true statement. So you say a equals all real numbers, or use that double stroke r if you want. Solve each inequality and graph its solution. Let's see. I'll do number 6 over here. When we're solving that inequality, we want to isolate our variable on one side of the inequality, preferably on the left side. Makes it a little easier to use some of our tricks. To graph, I'm going to distribute that 5. Now I've got 85 is less than 5 minus 10n. Subtract 5 from both sides. We've got 80 is less than -10n. To get rid of that -10, I've got to divide both sides by -10. I just divided by a negative number, so I need to flip my inequality to make this -8 is greater than n. Or flip it around again, n is less than -8. I'm going to put a point at -8. I check back to my inequality. It's going to be an open circle because it doesn't have the or equal to. And the arrow is going to go to the less than side, or the left, because of this less than symbol here. Let's go over solving a compound inequality and graphing solution. We'll do number 7 here. Yeah, number 7 is a good one. I'm going to solve these both individually. The left-hand side here by multiplying 9 to both sides to get that n is less than -9. Over here, I'm going to divide both sides by -3. I just divided by a negative number, so I need to flip my inequality to make this n is greater than -4. So open circle at -4, arrow going this way. Open circle at 9, arrow going this way. And we knew it was going to be a line with a gap because of this or here. All right. Solving equations with absolute values. So when we're doing this, I'm going to do number 11 over here. 6 times the absolute value of -4 plus 10n plus 8 equals -76. When we're doing this, we want to isolate that absolute value bracket to start. I'm going to do that by moving these numbers away, starting with that 8. 6 times the absolute value of -4 plus 10n equals -84. Now is a good time to divide by that 6. We divide by it in this step because if we had tried to divide by it in the previous step, we would have also had to divide this 8 by a 6. That would have made this take just a little bit longer. So now I've got the absolute value of -4 plus 10n is equal to, I think that's -14. Would make sense. I might as well double check. Yep. Now that the absolute value bracket is isolated, we're going to split it into the two cases. One case, the bracket doesn't have a job to do, so it just gets dropped. The value inside is positive. Actually, at this step here, we should actually stop because we've got absolute value equals a negative number. Absolute values can never equal a negative number. So once we reach this point here, we do that little check. Is my absolute value equal to a negative number? It is. This has no solution. Just see if that's right. Number 11, no solution. So number 11, there is no number that will make that equation true. Let's just do 10 real quick since we didn't see an example of actually solving it. I'm going to start by dividing both sides by 8. Now I've got the absolute value of n plus 6 equals 4. At this point, we split it into the two cases. One case where we drop the brackets entirely. N plus 6 equals 4. The value is positive, so it doesn't have a job to do. Subtract 6 from both sides. I've got n equals -2. And over here, I replace the brackets with a negative parentheses. Everything else stays the same, just the brackets become a negative parentheses. And I solve from there. Divide by that -1. N plus 6 equals -4. Subtract 6, subtract 6. N equals -10. So -2 and -10 for problem 10. Always a good idea. Check in your answers. All right, solve each inequality and graph its solution. So now we need to do the split, simplify each, graph each. So this one here splits into the positive case, p plus 3 is greater than 3, and the negative case, negative parentheses, p plus 3 is greater than 3. This one over here becomes, where to write it, p is greater than 0, and this one over here, after I divide by that -1, that flips my inequality. P plus 3 less than -3, subtract 3, subtract 3. P is less than -6. Let's go to that number line, put a point at 0, leave it open, arrow coming this way, put a point at -6, leave it open, arrow coming this way. So our answer is either that graph or both of these separated by the word or, because they made a line with a gap. That gives us an or inequality. Sketch a graph of each line. I guess we'll do number 15. In order to graph this, I'm going to get it into slope-intercept form, or you could sketch by using intercepts, however you want. I'm going to add x to both sides, -4/3 y equals x minus 4. To get rid of a -4/3, I'm going to multiply by a -3/4. To every single term, that's going to be a positive y equals -3/4 x plus 3. -4 times -3/4 is going to be a positive 3. Now I put a point on my y-intercept of 3, go down 3/4. Can't keep going this way, so I could go up 3 backwards 4, and connect those up with a straight line. Let's see how number 15 turned out. Relative to our answer key, yep, that looks about the same. All right, slope-intercept form of an equation that goes through 2 points. First thing I need is a slope, so I'm going to label these x1, y1, x2, y2. Then I'm going to put them into our slope formula, y2 minus y1 over x2 minus x1. You got to have this formula memorized. -2 minus 4 over 0 minus -4. Get a slope of -6/4 or -3/2. That's my m. I'm not done. Now I use that slope with one of these points to figure out what b is. So y equals mx plus b becomes, I'm going to use the second point, -2 equals -3/2 times 0 plus b. This cancels out. -2 is my b value. Now I'm ready to write the full equation. Y equals -3/2 x minus 2. That's for number 16. All right, write the slope-intercept form of the equation for the line described. It's perpendicular, so I got to take the slope. To get a perpendicular slope, I need to take it, find its opposite reciprocal, so I flip it upside down. That makes 2/1. And then I make it equals this. Then we got to make it opposite, so -2 is my slope. It's going through this x, y, so I'm going to borrow those points to find my y-intercept. Y equals mx plus b becomes 1 equals -2 times 1 plus b. When I plug those in for x and y, 1 equals -2 plus b, add 2, 3 equals b. So now I can write my equation as, establish that. Y equals -2x plus 3. All right, graph each equation. We're going to do this using transformations. Our parent function is a v-shaped graph centered at 0, 0, because this is an absolute value equation. I need to flip it upside down, stretch it by 3, and move it 4 to the left. First thing we do is reposition our vertex. The vertex was at 0, 0. Now it's moved 4 to the left. There's our vertex. My hint is that the a value gives you the slope going to the right of the vertex. So to the right of the vertex, I need a slope of -3. That could be down 3/1, down 3/1. And now I just make it symmetrical over the vertex to get the rest of this graph. So use the h and the k value to position the vertex, and then use the a value to figure out the slope going to the right of that vertex, then make it symmetrical. Let's practice that again with number 20. My vertex should be at 4, 3, because that's my h, k value. So 4, 3, put my vertex. Slope of 2 going to the right, so up 2/1. Make it symmetrical. Connect them up. Arrows at the end. It's easy as that. Sketch the graph of each linear inequality. I'm going to put a point to my y-intercept. I'm going to use the slope to get some more points. -3/2 means go down 3/2. Down 3/2. You can't keep going that way, so I could go up 3 backwards 2. Now I look at my inequality symbol. This is just a greater than, so I want to connect these up with a dotted line. It doesn't have that or equal to part, so we don't want to include the line itself in our solution. And then I got to decide which side to shade. It's a greater than. Greater than makes me think I need to shade above. And I'm going to double check this by picking a point that's in my shaded region and seeing if it makes the inequality true. Let's pick the point 3, 0. Actually, let's pick 2, 0. So then this becomes a -3 plus 2, that's a -1, is 0 greater than -1. Yep, checks out. All right, on to the next page. All right. Describe the transformations necessary to transform the graph of f(f) into g of x. Feel free to draw arrows to different parts to help with your explanation. So I can see that this 2 is out in front. I know that's going to cause a vertical stretch. You could say a vertical stretch of factor 2 if you want. Adding directly to the variable moves us left 3, and then tacking on a number at the end moves us up and down. A -2 will move us down 2. That's all I want for that. Over here, this is going to be a vertical compression and a vertical flip. Vertical flip. And you could say it's a vertical compression of factor 3. We'd call it factor 3 because it's getting 1/3 as tall. But all you have got to write here is vertical compression. And you've got that one. Let's just finish this one out. This is moving up 1. All right, sketching piecewise. Let's pick one of these, maybe something with an absolute value like number 26. First, I look at my transition values of -3 and 3. Those are the values that are incorporated into these inequalities over here. And I add vertical lines at those values. So vertical line at -3 and vertical line at +3, cutting my graph into 3 strips. In the first strip, I want to graph this equation. I rewrite it with a y equals just to help myself out. Y equals -x minus 1. That's going to have a y-intercept of -1, a slope of -1. I'm not going to keep going this way because I know the only part that I want to keep is the part that ends up in that first strip. So this is the part that I'm going to keep of that line. Now I got to decide on an endpoint. Its inequality doesn't have the or equal to, so it's going to be an open circle right there. Erase these points here. That just helps me to get that first piece. All right, on to the next piece. I'm going to rewrite it with a y equals. Let's do this in red. A little contrast, y equals 1. That's going to be a horizontal line at 1, but I only want to keep it in this strip here. It's got 2 closed circles at the ends. So closed circle, because the inequality does have those or equal to's. And the last one is negative absolute value of x. That's going to be our parent function, but flipped over. But I know I'm only going to keep the part that ends up in that third strip. So all of this gets erased. And then it's going to start with an open circle because it doesn't have the or equal to. All right, that's what number 26 should look like. Let's just see if we got it. Yep, looks good. Be always checking your work on these ones. Notice in 27, 2 lines match up end to end, so we don't need an open or a closed dot there, just the angle is fine. There's no need for a dot right there. All right, final page. We're doing a regression. This equation is blank down in yours. You've got to fill that in. Let's see how to get that. Using my on-screen calculator here, we'll go through this problem number 29. All right. So I need to get the data into my calculator. So I press stat and then enter. My lists already have stuff in it, so go up to the top and clear them. All right, so I've got a 2, a 3, a 4, a 7, a 9, and an 11, being sure to press enter between each data point, then match these up over here. Their win probabilities. You can see already that as our rank in the tournament goes down or goes up, like higher rank, worse team, our win probability is going down. All right, we're going to use that trend to see if we can make some predictions. So now I got to do the regression. How do I do that? I press stat first. Then I go over to calculate. I go down to linear regression and press enter. If you want to store this regression equation, you don't have to, but if you want to, you can go vars over enter, enter on store regression equation. If you didn't want to do that, you can just go press enter. And there's your equation right there. You can see that these values match what's given over here. Y equals, there's my slope of negative 6.58 is what they rounded it to. There's my y-intercept of 106. All right, let's see if we can use that to answer some questions. What does the slope of this line represent? And I'm going to write this out. This is how I want you to write it on your review sheet and on the test. All right, for each increase of 1 in our rank, we can expect a decrease in our win probability of about 6%. Was that what it was? No, let me get that back. Yeah, about 6%, 6.5%. I think it's fair to say. All right, how do we answer this next one? The school has a rank of 6. What's the probability of winning the first game? So I did store my equation in the calculator, so now I can use the calculator. If you didn't do that, you could just plug in 6 for x, but I'm going to go to second window table set, have it start at 6, and look at my table. You can let them in. And there I can see my win probability of 66.5%. 66.5%. All right, there's our regression. Explain the difference between extrapolating and interpolating. I feel like you guys are pretty good at that. Extrapolating would be within the data, just like we did for our win rank of 6. This one is true, this one's false. All right, that's the end for this video. Good luck studying. Have a good rest of your